Math 8, Topic 1 Test Review. So in this video, we are going to review the Topic 1 test so that you can fix some of the questions you got wrong, learn why you got them wrong, and earn some points back. Let's begin. Oh, also, before we begin, let me tell you, if you have gotten a question right, for example, if you have gotten question number 1 right, there is no need to listen to me tell you how to get it right because you already know. So fast forward through this and go to a question that you got wrong. Maybe you got number 2 wrong or number 7 wrong. Go to the question you got wrong and fix that. There's no need to take extra time on problems you've already gotten correct. These are for what you missed, what you got incorrect, and to give you a chance to work them out the correct way and get the right answer. Okay, number 1, order the following real numbers from least to greatest. And so we have 5 numbers: 10 thirds, 1 2/10, 1/5, pi, and the square root of 17. So they're 5 numbers and they're all in different formats, right? So we have a couple fractions, a decimal, pi, and then a square root. When you have numbers that they want you to put in order and they're in different formats, you need to change them to decimals. You got it. So we're going to need our handy dandy little calculator. There it is. And we're going to change our numbers into decimals. So the first number that we have is 10 thirds. So when it's a fraction, this bar right here also means division. That's what that bar means. So we can say 10 divided by 3 in our calculator and get the correct answer format for a decimal. So 10 divided by 3, and let's move it down a little bit. There it is. 3.3 repeating. So that's the 3's for forever. So I'm going to grab my little pencil here, and I'm going to write down that 10 thirds is equal to, and I'm going to use a couple 3's just to show that it can keep going, 3.3 repeating, just like that. Now 1 2/10, that's already a decimal, so all you need to do is write it underneath. Again, make sure your decimals line up. And what's that number we can write right here so that we have the same amount of numbers, the same place values? Excellent. It's a 0. So you're going to put a 0 there just so it all lines up pretty. All right, we go back to our third option, which is 1/5. And I need my handy dandy calculator. And we're going to say 1 divided by 5. 0.2 or 2/10. So when I come over here, I'm going to write down 1/5 equals 0.2. And again, what can go behind this 2? A 0. If it's not repeating, you always put a 0 after it. Now we look at our fourth number, and it's pi. Some of you might have pi memorized. That's awesome. You might even know more places than I do of pi, which is even cooler. If we go to our calculator and hit the pi button, it gives us a whole bunch of numbers. Because, you know, pi is irrational. Never repeats, never ends, just keeps on going. For our problem, we're just comparing numbers. So we just need the first 2, 3.14. So that's all we're going to worry about writing down. So we come down here, put our little pi, nothing fancy, and we're going to have 3.14. And again, making sure all of our place values are lined up. The last one is the square root of 17. Now this is a problem, just like 2 plus 2 is 4. So we need to put it in our calculator to get an answer. So we're going to hit 17, and then you want to find this symbol, the square root symbol, although I don't believe yours has a 2. It's just the good old-fashioned square root, and it has an X. When you click on this button on your calculator, it will find the square root of 17. Now this is also irrational because it's not a natural number that comes up. So we're going to just take the first couple of decimals because all we're worried about right now is comparing. So we'll write down the square root of 17, and we're going to write down that it equals 4.12. And again, that's an approximation. Does it equal 4.12 exactly? Well, no. It has all these other numbers. But it's close enough for what we need to do. All right, so we have all of our numbers in decimals. Line them up. Now again, if you, ooh, that's a crooked line. My bad. So if you have all your decimals in line, then ordering them should be a little bit easier, I would think. We are going from least to greatest. So let me get rid of my calculator here because we don't need this anymore. And we are going to order them from least to greatest. It's always a good idea to go back and double check that. So I want the smallest number. You start on the left side, just like we read our sentence, right? We start over on the left side and go this way, order the following. When we read our numbers, we start on the left side and go to the right. So if we look here, we have a 3, a 1, a 0, a 3, and a 4. This 0, well, that's my smallest number, so that has to be number 1. I'm not even looking at the decimals because this is the smallest in the ones place. Now, I want you to stop for a minute because something I hear a lot is kids are like, oh, this test is so long, I can't do it. But if we stop right here and go back to our answer choices, look at this. This has 1/5 first. And C has 1/5 first, but B doesn't, and D doesn't. So right now, just knowing our first number, we've eliminated half of our options. Now you got a 50-50 shot, even if you don't know what to do next. But let's go ahead and see what's next. So 0, we've taken care of that. We're back to 3, 1, 3, 4. Well, obviously, 1 is going to be my next smallest. And we go back over here, 1.2. Oh, they both have 1.2, so that's not going to be helpful. So let's go find number 3. I have 2 3s, one here and one here. So now you have to go to the 10th spot. I have a 3 and I have a 1. What's smaller, 1 or 3? Good. This one's smaller. So I'm going to stop here because my job is not to tell you the answer. My job is to try and get you there on your own. So I've gotten you as far as I'm going to take you on this problem. You're down to a 50-50 shot. You need to tell me, is it A or is it C that's the correct answer? All right. What I want you to do is pause. Now, pause the video. If you miss number 1, you need to write all this down to show your work, and then you circle either A or C. Okay? So pause the video, and when you come back, we'll do number 2. Okay, number 2. Look at the number line. Which point represents the square root of 196? The first thing you want to do in this problem is figure out what is the square root of 196. Bring up our handy-dandy calculator, and you type in the number first, and then you hit your square root button. 14. All right, so to show work for this problem, you would write down, I like my blue, the square root of 196 equals 14. Now, it's crooked 4, but that's okay. You guys get it. All right, so now what you do is you come to your number line and you say, okay, well, which of these letters is at 14? And if I'm looking correctly, here's your 14. What letter is with it? That's your answer, because 14 is the point, right? So that's your answer. I'm going to stop here. You need to make sure you have this work written down and circle the correct answer. Pause the video. When we come back, we'll be on number 3. All right, number 3, directions. Click on a box to choose each number you want to select. You must select all correct numbers. And it is asking you to identify each integer. So I'm going to give you a hint because I have worked for the State Department in building these types of questions, so I have a little insider information. When it uses the word each, it has to be more than one. Like, there are no exceptions. There's no, oh, but if it's this. No. If it says you must select all correct numbers, it has to be more than one. So if you did number 3 and you got it wrong, it could be that you only picked one answer. That answer could have been an integer, but because you didn't pick all of them, the entire question is wrong. So you have to be very careful on these whole, select all questions, because one wrong move messes up the whole thing. Now, the way to answer these questions is if you look at a couple of them, these 3 in particular, 1, 2, and 3, if you look at these 3, you will notice that they are actually problems. For example, the square root of 81 is 9. Good. And then we have 64, what is that? Divided by 4. And this is a negative 2 divided by 3. So you need to actually solve them and then look at the answer to determine if it's an integer. Obviously, you need to know what an integer is. Very important. Now, without going into a whole bunch of details, remember that real number system that we've been working with this year? So it's broken into 2 main parts. The real number system, you have your rational numbers and you have your irrational numbers. Rational numbers are any decimal that stops or terminates, or it repeats, like 0.3 repeating or 5 repeating, anything that repeats or stops, like, I don't know, 0.25, right? That stops. It's rational. Irrational numbers are like the square root of 17. It doesn't stop. It goes on forever, and it never repeats. Those are irrational. Doesn't matter if they're positive or negative, either one. If it doesn't stop or doesn't repeat, it's irrational. Now, inside rational, you can get more specific. You can have the first layer is going to be your integers, and that is what we're looking at in this question, integers. If you were to draw the number line that you guys are used to, right? You have 0 in the middle, and on the right side we have, good, 1, then 2, excellent. I hope you're writing this down if you got this problem wrong. What's on the left side? What's next? -1, exactly. And then -2. Did you put -1.5? No, I don't think you did. Did you put 0.5? Did you go halfway in between? No. You put the whole numbers or the opposite of the whole numbers. These, my friends, are your integers. The way you would make a normal number line are your integers. Positive numbers, right? Your positive whole numbers, your counting numbers, zeros in the middle, and then your negative whole numbers. Couple of things I want to clear up, and then you're going to circle these on your own. If it has a 0.0, like this guy right here, does that change the -21? Or would you still put -21 as a line way down here somewhere? Does 0.0 count? Because 0.5 sure counts, right? You wouldn't put that. But what about -21? That would be okay. And also, I've gotten questions, well, I know 2/3 a fraction, but it has a negative sign. So doesn't that mean it's automatically an integer? No, it does not. Fractions can be negative. Decimals can be negative. That has nothing to do with it. Integers have to be whole, okay? No decimals, no fractions, nothing like that. So at this point, I want to make sure you write it down, and I also want your answers for this guy and this guy. And then I want you to circle whatever numbers you think are integers. Remember, integers, positive and negative whole numbers, including 0. Pause the video and move on. Okay, we're back. Number 4, type your answer in the box. What is the negative square root of 324? Well, whenever I see the square root sign, I know I need my calculator to help me solve it. So a couple of you guys have done this. Now this is the best wrong way. Does that make sense? It's what most of you guys do, and then you raise your hand during the test and you're like, I don't know what to do. So I'm going to tell you now what you do. You have 324. And then you hit the negative sign, right? Because there's a negative sign there. Totally makes sense. And then you hit the square root button, because that's what it says. Uh-oh. It says not a number. On your calculator, it will say error. So it's like, wait, what did I do wrong? Where is my negative sign right here, guys? Where is it? It's on the outside. So it's not the square root of negative 324. It's the negative square root of 324. So what you do is you just do 324 and then hit the square root sign and then the negative positive button. Okay? So again, I'm not doing this for you. I am showing you, this is a total calculator problem. No like mental math involved. The square root, this part comes first. Hit equals, and then my fine feathered friends, you hit that button. Not before the square root. This is the very last button you're going to hit. Okay? Write this down, or just, circle or whatever you want to do, and then give me the correct answer in the box. Hit pause, and then we'll move to number 5. Okay, here we are, number 5. Which number is an irrational number? Now remember a couple questions back, we made our pretty handy dandy little real number system graphic organizer, and we split it and we said, okay, this is rational, right? So on this side we have all the numbers that make sense, that are rational. So we have all our fractions, we have decimals that stop or that repeat, like 1/3. We have all of our integers, because that's the next circle is your integers. And then inside that, if we go to where we start at 0, then you just have your whole numbers. And then even inside that, we talk about the numbers that you can go outside and count, or our natural numbers. Well, on the other side of this is a very much smaller category, in the terms that it's just one word, it's just one thing, which are your irrational numbers. Now, irrational numbers are any decimal that doesn't stop and doesn't repeat. Pi is a great example of irrational. Also, you could have a pattern, but the pattern does not repeat the same numbers. You see that? See, it's 1, 0, but then it's 1, 1, 0. So see, it's a pattern, but it doesn't repeat the exact same numbers. So that's irrational, because there's no way to simplify this, to write it smaller. You can't write a bar notation because it doesn't repeat exactly the same. Also, anything that is not a perfect square, so the square root of 8, the square root of 29, the square root of 31, anything that's not perfect would go under the irrational side. So now I want you to look over here. If it has a square root symbol, you gotta figure out the answer. If it is not perfect, meaning you hit that square root button and it doesn't give you a whole number answer, it's irrational. If it does, then it's one of these things over here. Maybe an integer, maybe a natural number, but it's something on this side. We are looking for irrational. And remember, since it says which one is, only one of these will work. So you're going to have to do some math, write down the information I have up here, and then let's move on to number 6. Number 6. click and drag the numbers to the correct box. Click and drag the numbers into the smallest subset of real numbers. Each number must only be used once. And so it gives us this nice, pretty real number system. And there are rational numbers versus irrational, separate sides. They don't mix. But inside real numbers, you can get more specific, or the smallest subset. And so we have integers, whole numbers, and I know this got cut off, but this is natural numbers down here. And on your computer, you clicked each one of these options and you drag them to one of these, what is that? 1, 2, 3, 4, 5 spaces. 5 numbers, one goes in each spot. So if it is a square root, remember you must figure it out first. Please figure it out first. So what is the square root of 18? What is the square root of 64? And while the square root of 18 you may have to estimate, approximate, round, that doesn't mean that it stops all of a sudden. If it keeps going, then we know it's going to be irrational. If it stops, or if it's a whole number, it's going to go on the rational side. But which rational one is it? Remember, natural numbers are things you can count in nature. Can you count 1,000,000 trees? Sure. Would you want to? No, but you could. There's only one number that's a whole number that's not natural. Integers we did above in number 5, so that's positive and negative whole numbers. And then rational numbers are going to be decimals, fractions. They can be positive or negative, doesn't matter. So again, I'm not going to tell you the answers. I think I've given you enough hints to make sure that you solve these before you place them into their spots. And so for number 6, to get the correct answer, they all have to be in the right spot. So if you get 1 or 2 right, but the others are wrong, the whole thing's wrong. So what I would like for you to do now, pause the video, write these 5 where you think they should go after the explanation of each, and then move on to number 7. Number 7, look at the number line. Which value could be represented by point A? So in a question above, they gave us a problem and we had to find the point. In this question, they're telling us what point to use. So I don't even care about these other points. I care about this guy right here. That's the only one I want to worry with. A lot of students miss this one, and that's okay. It's a learning process. It's not the end of the year. We have time, because they picked A. And I'm going to tell you why A is wrong, but then you have to pick the right answer on your own. What is in front of that 11.8? Because 11.8 totally looks like the right answer. I'm with you. I understand why it's the best wrong answer you got. 11.8 is wrong because of this guy right here. That square root symbol, because that means you have to do something to the 11.8. In fact, you have to do something to all of them. You actually have to put them in the calculator. So if we bring up our handy dandy calculator and put in 11.8 and hit the square root button like it says, well then I get this teeny tiny number, 3, and I'm just going to round, 0.44. Does this right here represent 3.44? No, of course not. It's got to be something that's between 11 and 12. So automatically it's wrong. Don't just go for the easiest answer, because very rarely will that be right. You really need to do the problem. Now that you know how to do it, you need to figure out the answers for B, C, and D, and mark the one that's between 11 and 12. Pause the video, write your work down to get all your points, and then move on to number 8. Number 8, which list of numbers is ordered from greatest to least? All right, so in this case, again, we are given a list. They are 4 numbers. They're the same four numbers, but they're all in different orders. So since they're in different formats, yep, I'm going to change them all to decimals. Good job. And then I'm going to order one and see which one matches what I need. So we're going to take our blue pencil. What do we do with percents? Do you remember? Yes, very good. We divide by 100. So you're going to put 52 in your calculator. See if I can get mine up and working here. All right, so we have 52 divided by 100. 0.52. All right, so come over here, and I'm going to write 52%. And I like putting the original by my decimal because it saves me that step in the end of trying to figure out how to match them. You don't have to do that if you don't want to. Is 0.52 or 52 hundredths because that's what I divided by. All right, 0.45. Don't have to do anything with that because that's already in decimal form. Now, do you guys remember how to do scientific notation? 3.1 times 10 to the first power. There are two ways you can do scientific notation. Completely your choice. That's a one. One, if you know how to do it in your head by just moving the decimal one place, you may do that. Or you can put it in your calculator. So I'm going to show you real quick how to put it in your calculator. You type it in pretty much as like order of operations. So you type it in just like you see it. 3.1 times 10 to the first power and then hit equals. So you're going to do 3.1 times 10. Now stop here. Don't hit equals yet because you have your exponent. So you guys, right here, I have x to the y power. You have y to the x above your division key, your division button on your calculator. So you're going to click on that. And now your calculator doesn't change. See, I still have the 10 showing. That's because it's waiting for you to tell it what exponent, what little number do you want. In this case, I want the number 1. So I'm going to click 1 and now click equals. Pad out. And your decimal on your calculator, it's not on mine, but on your calculator, you'll see a little decimal point right after the 1. When you have a whole number, a natural number like this, you make it money. So when I write it over here, I'm going to make it money and make it $31, just like that. Now, just by looking at what we have here, this looks like it's going to be the biggest number, but I do want to do my 10/11ths just so I have it written. It's a fraction, so I'm going to divide 10 divided by 11. And I get a repeating decimal. Now, some of you guys are going to have this 1 at the end. It doesn't mean it all of a sudden changed. Your calculator rounds when it gets to the end of the screen because it doesn't know what else to do. But this is a repeating decimal. It's 90. See that? 90, 90, 90. It repeats. So I'm going to write that down. My 10/11ths is equal to 0.90 repeating. So I'm going to put my bar over both numbers because it's not just the 9, it's 90 that repeats. Make sure everything's lined up. And then I'm going to go back to my directions and I'm going to see my order. So remember, this one's different. Greatest to least. So I want my biggest number first. Obviously, the 31 is huge. So that's my first number. Stop here. That should be a 1. Stop here. Let's go back. Does the scientific notation come first here? Nope. Yes. Nope. And yes. So now it's going to be between B and D. Now, because we've done one like this before, I'm going to stop and let you figure out 2, 3, and 4 to see which one you should choose, B or D. Make sure you write this down. Pause the video, get everything written down, and then when you come back, we'll do number 9. Number 9. Which number in this list is not an integer. 12/4, -4 squared, the square root of 25, or -4.8. Here's your key. Look at that. And yes, it is nice and bold and capitalized and everything else. It is not an integer. That means 3 of these things are going to be a whole number that's either positive or negative. An integer cannot be a fraction or a decimal. Well, we have a fraction and a decimal, but you have to solve them. What is 12 divided by 4? What is -4 times -4? Because isn't that what -4 squared is? What's the square root of 25? Is there anything that you need to do here, or is it already done? So finish filling this out, and remember, we want the one that's not an integer. Okay, so I'm going to write this out. Okay, I'm going to put it over here. An integer. Let's see if I can move this down here. Oh, no, won't let me move it. Okay. What if I erase it? Let's try this. Nope, still does it. Okay. Not fraction or decimal, which I know doesn't really help because it's like all in the thing, but it won't let me change it. So it is not a fraction or a decimal. I got it. How about I do this and then I just redo it over there? Oh, look at me. I'm so smart. Not, try again, a fraction, not a decimal. Integers, not a fraction, not a decimal. It's a whole number that's positive or negative. So now I want you to figure out which one it is. Pause the video, write all this good stuff down, mark it, and let's move on to number 10. Number 10, which number is a perfect square? So here are your keywords, perfect square. And remember, a perfect square is when you have a number that when you hit that square root button, gives you a whole number. For example, if I did 25 and hit the square root button, I get 5. If I did 100, I would get 10. If I did 400, I would get, hang on, gotta get that cursor to move. There it is, 20. 196, we had to do that earlier. 14. Those numbers, 196 to 400, 25. Those are all perfect squares because when you hit the square root button, you get a natural number. So what you need to do to solve this problem is you are going to take the square root of each of these and you are going to figure out which one gives you a whole number, a counting number. And when you do that, 3 of these are going to give you irrational numbers, decimals that go on forever. One of them will give you a whole number, a natural number. Pick the whole number. There is your perfect square. Write down work, and for the others that don't work, you can just write decimals, like just a few numbers. You don't have to write the whole thing, just to show that you know it's not perfect because it gave you a long decimal. Okay? Pause the video, write your work down, and we'll move on to number 11. Number 11, drag each number to the correct box. Arrange the numbers from least to greatest. Now we've done a few of these, so this should not be difficult at this point. The key here is even if you get 2 in the right box, if you mess up 2 other ones, the whole question is wrong. So this is one of those what we call TEI questions, your technology questions, where you have to make sure that all 4 are in the right spot. Since they are in different formats, you guessed it, I'm going to put them into decimal form. You know that you divide this by 100 because it's a percent. You know that This division bar right here, this fraction bar, means to divide. Be careful with this negative, okay? That means the decimal is going to go to the left. It also means when you put it in your calculator, remember how we worked with that before? And let me put it down here. You can put 3.01 times 10 and hit that y to the x button. But now when you hit your 1, you have to make sure you hit that negative sign before you hit equals. Don't make it a negative 10. That's not it. It's a negative 1 that's the exponent, because then it's going to be a smaller decimal. And then 3.1 you don't have to do anything to. You need to make sure that you put this in order from little to big. Now, because this is number 11 and we've gone through a couple others like this, I'm going to let you do this one on your own. Remember, you need to line up your decimals. So your ones go over here, your ones place. Oh, sorry about that, guys. Your ones place goes over here, tenths, hundredths, right? They go over here. You shouldn't need more than 3 decimal places at most. And you have 1 or 2 in the front. And I want you to line them up. And then I want you to put them in order from little, or from least, little to big, least to greatest. Okay? Pause this video. Do the work on your paper. Put them back in the original form here. And then move on to number 12. Oh, and when I say original form, if you know that 30 divided by 100 is, what is that, 0.30, right? 30. Don't write 0.3 down here. You need to write the 30% at the bottom, because that's the original form. So that's what you need to write down here when you rewrite it. Okay? All right, pause the video, get your work done, and I'll see you on number 12. Okay, number 12. Julie has a squared shaped driveway with an area of 256 square feet. What are the dimensions of the driveway? All right, so let's look at some important words here that we need to make sure we understand. First of all, squared shape driveway. So now I'm going to get fancy on y'all, so be careful. I'm going to try my best to make a square. Bear with me. Oh, almost. Wait. Oh, close enough. Yeah, you good with that? I'm good with that. All right, so there's my square-shaped driveway. Feel free to draw your own. Now, we know that inside our driveway, we have an area of 256. So they want to know, what are the dimensions? And remember, dimensions are length times width. What are your dimensions of this? So what is your length and what is your width? Now, here's the biggest hint I can give you. What do we know about the sides of a square? They're all the same, right? So hint, hint, hint. Can A that has 2 different numbers be a square? No, it cannot. So you can get rid of half of the answers right now, because a square has to have the same numbers. You can either find the square root of 256 to find out what the side is, or you can just multiply these and figure out which one gives you 256. Either way, show your work, whether you did the square root of 256, or if you did 16 times 16 or 15 times 15, show me your work. Pause the video, and then I'll meet you on 13. Number 13. Click on a box to choose each number you want to select. You must select all correct numbers. Identify each number between 1 and 7/10 times 10 to the 0 power and 195%. Again, the tip of the day, right? If it says each, it has to be more than 1. Can it be 3? Can it be 4? It could be, but it has to be more than 1. So if you select 1 and move on, that's why you're getting it wrong. So the way I like to do this problem is I make a number line, right? So I'm going to use my fancy dancy number line over here. I make a number line, and I put my two numbers on either side. But first I want to change them so they're just decimals because this is a little too much. So if I grab my calculator, okay, and I put whoops, gotta get my pointer tool. If I put 1.7 times 10, and you can do it with 0. Hit that Y to the X button and then hit 0. You get 1.7 because all that 0 does is changes the 10 to a 1. That's really all it does. And in fact, a 0 to any number, for 0 being the exponent, will change any number. You could have 1,000,000 to the 0 power will be 1. So your answer in this case is 1.7. So I'm going to mark my lower side because it says between. So I'm going to mark this side with 1.7. And this one we know, right? You just divide by 100. And just to save some time, I'll give you that one. That's 1.95. So I want a number bigger than 0.7 but smaller than 0.9 or 95 if it gets to that range. So what do you have to do? Well, you have to solve these. This one you don't have to solve, but this one's huge. That's 18. 18 is way bigger than 1. The rest of them I want you to solve on your own and circle the ones that are right. Remember, when it's a mixed number in your calculator, 7 divided by 8 plus 1. Because order of operations will divide first and then add 1. That will give you your decimal form of a mixed number. All right, do the scientific notation one on your own, 7 divided by 4 on your own, and then circle the ones that are in between. 1, you can think of it like money, $1.70, $1.95. What's going to come in between? Pause the video, write down your work, mark your answers, and we'll move on to 14. Number 14, which pair of numbers are both between 6 and 7? And then they give you a whole bunch of different square roots. Couple ways you could do this. You could find the square root of every number and see which ones are between 6 and 7. Or you could change 6 to what would the square root, what would 6 squared be, right? 36, because the square root of 6, or the square root of 36 is 6. And 49, right? You could work it backwards. That's always an option. So then which of these numbers are bigger than 36 but smaller than 49? So here's a key, and I actually had this question yesterday. If it says between, does that mean exact? No, it doesn't. Okay, because they give you 36 and 49 exactly. No, just like we did on number 13, if I'm talking between, that means I want, here's 6, here's 7. I want two numbers that are between them. Not exactly 6, not exactly 7. And I don't care if they're all here, I don't care where they are, but they have to be between these. So what I'm going to tell you is you can either look for numbers between the square root of 36 and the square root of 49. Or, and this is absolutely okay too, you can figure out what each of these square roots are as a decimal and see which one is bigger than 6 and smaller than 7. And remember, it has to be the pair. So say that 42, the square root of 42 is bigger than 6 but smaller than 7. Does that mean the square root of 30 fits too? Because if one fits and one doesn't, you got to mark it out. Pause the video, show me your work, pick your answer, and I'll meet you on 15. Number 15, identify the number with the smallest value. So it gives you 4 numbers. This is a lot like putting it in order from least to greatest, right? Gives you 4 numbers. You got to figure out the smallest one. And again, I heard a couple of you guys being like, I have to do this again? Well, yeah, this is a pretty important thing to know, is to be able to order numbers, to know what's big and what's small. That's important in life. So you need to do the math for each of these. 31% You got to divide that by 100. 13/40ths, that means divide. 13 divided by 40, what does that give you? This is already in decimal form. We talked about this negative exponent. So you do it in your calculator, 3.09 times 10, y to the x, 1 negative, then hit equals. Do me a favor, make sure that when you're putting them in order, I would use probably 3 decimal places and make sure all your decimals line up. Then you want to pick the smallest value. Now I'm going to give you a hint. They all start with 0. So you're going to need to look at your tenths or your hundredths place to figure out the smallest. Okay? And remember, even if a number is bigger, like there are more numbers, doesn't necessarily mean it has the biggest value. As soon as they're different, like if it's 3, 3, and then it's 0 and 2, this one's smaller, no matter if it has 15 more numbers behind it. So go step by step, place by place, and find the one with the smallest value. Show me your work, circle your answer, and then we'll move on to 16. Which statement best describes the square root of 50? So this one is relatively easy. You need to do the square root symbol right here, and you need to do the square root of 50. So to show work, you say the square root of 50, and you write down your answer, which I think is going to be 7 point something, 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 something. Then you need to look at the words exactly and the words between. Is it exactly 7? Don't round, don't approximate. They mean, does it equal 7, period. Is it exactly 25? Is it between 7 and 8? So when they mean between, again, you have your number line, you have 7, you have 8. Is it somewhere in between? Doesn't have to be exactly in the middle. Could be closer to 7, could be closer to 8, but is it in between the two? Or you have 24, you have 25 here, and then you have 26 down here. Is it in between 24 and 26, somewhere in this area? The only way you're going to get this question correct is if you actually do the square root of 50 in your calculator. And then there should be no question as to the answer. So write your work down, circle your answer, and I'll see you on 17. Number 17, order the set of numbers from least to greatest. I know you guys are so excited to see another one of these. This time we have a lot of negatives involved. So it's important to know the bigger the number of the negative, the smaller the value, right? The further you get away from 0, the smaller it becomes. So I don't think you guys need any help with setting these up. So just make sure that you're lining up your decimals. Make sure that you divide them, right? So if we have, what is that, 9/25? You say 9 divided by 25, and then hit the negative sign at the end. And you can get a negative 0.36. Right? And then we're going to do, I'm going to put this up here. We're going to do 2 divided by 7. Oh, I forgot to hit equals. So that would help, huh? There it is. Okay, well, that's a big, long number. Now, even though it's a big, long number, because it's written like a fraction, automatically rational, don't let it throw you, because look what happens after this 4. 2, 8, 5, 7, 1, 4. It starts all over again, okay? And this 9 is rounding. So it actually does repeat. It just has like 6 numbers before it repeats. All right, so I'm going to approximate with this one. No need to write all those numbers. It's a positive fraction. And that's, I'm going to round to 29 because, you know, the 5 makes the 8 into a 9. And then the negative square root of 2. So again, 2 square root first and then hit the negative sign. Now this is not a repeating decimal, so this is irrational. And again, I'm just going to write down the first couple problems. So we have negative 1.41. I'm going to go ahead and put zeros here. And see, I'm lining them all up. I go back to my directions. You always go back because that took a little bit of work, right? So we don't want to forget. We're going small to big. Normally I tell you to start with the smallest, but in this case, we only have one positive number. And everybody who is listening to this video knows that positive is always bigger than negative, no matter what. So this has to be my negative. I have 1, 2, 3, 4, 5 numbers. So my positive number right here has to be number 5. So before I do anything else, I'm going to go through and mark anything that doesn't have the positive one at the end. Can't be C, can't be D. These two are out of the running because they don't have it at the end. Now we can go back. Please remember, look at these. Now somebody asked me today, can you have a negative 0? Well, no, you can't have a negative 0, but remember, it's not negative 0, it's negative, 36 hundredths. Yes, you can have a negative decimal. But if we just look here, our smallest number, because they're negatives, is the biggest one of these. So which one, 1, 2, or 3, is the furthest away from 0? This guy right here. So there's your number 1. Because negative 3 is the furthest away from 0. When you're thinking about a number line, and you have negative 1, negative 2, negative 3, it's way down there. It's the furthest away, so it's the least. At this point, you should know your answer. Please make sure you write all this work down. I'm not doing it for myself. I've already passed 8th grade. This is for you guys. Write it down, pick the correct answer, and we'll move on to 18. Almost done. All right, number 18, approximate, that means round, right? The square root of 23 to the nearest 10th and plot the number on the number line. So when it tells you to do something like this, the first thing you do is grab your calculator and you put in 23 and hit your square root button. Easiest thing in the world to do because there's not a lot for your brain to do except for remember hit the square root button. To show your work, you can write down the square root of 23 equals, and again it says approximate to the nearest 10th, right? So 10th is in your dimes. So I look here, what is that 9 going to do to the 7? Is it 5 and above or 4 and below? Good, it makes it go up 1. We got to give it a shove. 4.8. So now we look over here. Is 4.8 bigger than 5? Just a little bit smaller? Smaller than 4 or just a little bit bigger than 4? You got to know how to plot this on a number line. I'm not going to tell you. Where should you plot 4.8? What I need you to do to show me your work is to show me this piece right here. Write that down and then circle your answer. All right, pause the video, do the work, and I'll see you on 19. Number 19, solve for x. X squared equals 144. So what they want you to do is say which one of these could you plug in for x. If you paid attention to one of the lessons that we've done in September, you know that to get rid of a square, you have to find the square root. So to undo a square, you do the square root and then it cancels it out. But remember from last year, if you do one thing to the left side, what do you do to the right side? Yeah, the same thing. So now you have to take the square root of 144. Remember, negative times a negative, it's a positive. A positive times a positive is a positive. So when it has a plus, minus, or a positive, negative, like all of these do in front of it, it just means it could be a positive answer or it could be the negative version. Either way, you would get the same answer. So I'm going to stop here. You just tell me what the square root of 144 equals, and then you'll get your answer. It's very simple. Write down your work, and I'll see you on the last one, number 20. Okay, number 20, the last one. Order 3.21 times 10 to the 6th power, 4.2 times 10 to the 5th power, and 1.1 times 10 to the 9th power from least to greatest. Okay, a couple of things, and you may have forgotten from class last year, and that's absolutely okay. Whenever you have to order scientific notation, honestly, if you just look at the exponents, all you have to do is put them in order. Now, if you have the same exponents, then you can look at your decimals and figure out which one is our least to greatest. But really, just looking at since these have 3 different exponents, you could put the numbers 6, 5, and 9 in order from least to greatest, and the entire problem will be solved. Just to do the old-fashioned way, and so you know there's always a backup plan. You always want to have plan B. You can totally do this in your calculator and still get it right. So what you would do is you would put these numbers, 3.21 times 10 to the, where's my y to the x, 6th power, and you write this number down, right? So the first one, 3, 2, 1, and then what is that, 4 zeros? 1, 2, 3, 4. And then remember, count 3, put a comma. Count 3, put a comma. Now on yours, your decimal's right here. On mine, you don't see it, but on your calculator, you'll see a decimal right at the end. So then we go and we do the next one. 4.2. Whoops, that's not a 2, Miss Walker. Try again. It's getting late. 4.2 times 10 y to the x, and then we want the 5th power. And we have this big number. So that's 4 zeros again. So see how I'm going to write it backwards? That's so I keep my place values the same. And then I have a 2 and a 4. So already I know that 3.21 is bigger than this one. Now I don't know, this might be the biggest, but I know that 4.2 is going to be smaller than this 3.21. So if you look here, 4.2, and then 3.21, 4.2, and then 3.21. This one has it after, so that can't be right. See, it has 321 first? Nope. See how this one has 321 first? Nope. So what I'm going to do now is I've gotten you down to a 50-50. I want you to figure out where that 1.1 times 10 to the 9th power is going to go. Is it the biggest or is it in the middle? Show me your work for that last problem and then circle the correct answers. When you have finished going over all of your incorrect answers, please make sure your name's at the top of your paper and turn it into your teacher. Thanks so much for watching. Have a good evening or a good day. Bye.